So the hard part about this page of the logarithm and exponential functions test is that every problem is different. Every problem you have to use a different setup and a different problem solving strategy. This is a logarithm problem, and here we have to start by condensing. So we have that plus in the middle, and of course plus means multiply. So our goal is always going to be to condense and get either a single logarithm or a single logarithm on each side of the equation. So plus means multiply, so this is log base 9 of x minus 5 times x plus 3. And then, since we only have a single logarithm, we have to use the exponential in order to solve. Our base is 9. Our exponent is 1, and it's equal to this mess over here. So that's how you undo the logarithm. 9 to the first equals x minus 5 times x plus 3. And now it's an algebra 2 problem. You've got to undo that logarithm in order to solve for x. So x squared is 3x minus 5x minus 15. Double check my signs there. Positive 3, negative 5, negative 15. I need everything on the same side, so I'm going to subtract my 9 over. I'm going to combine my like terms. Since we have that x squared, that's why we need everything on the same side. We're looking for factoring or quadratic formula. You can do either. Here, I'm going to factor two numbers that multiply to negative 24 and add to negative 2 are negative 6 and positive 4. And that means x equals 6 and x equals negative 4. Before we get all excited and circle our answers, we just have to make sure that both work if we were to plug them back in. Remember, we can't take the log of a negative. So if I plug 6 in here, I'm good. 6 minus 5 is 1. Plug 6 in here, I'm good. 6 plus 3 is 9. So 6 is a good answer. Now let's check negative 4. And really, you just need one place for it not to work. So negative 4 minus 5 is negative 9. Since we can't take the log of a negative number, that is an extraneous solution. So our answer there is 6. Go ahead and do another problem, another logarithm problem on this video. Again, we always want either one single logarithm or one logarithm on each side. So since I see ln's on both sides of this equation, I'm going to condense so I have a single ln on each side, and then I'll be able to cancel them. Here, since I have a minus there, that's going to become divide. When I condense, x minus 1 over x minus 4. And now, since I have an ln on each side of the problem, or each side of the equal sign, just like if I had a 2 on each side of the equal sign, they cancel. So I have x minus 5 is equal to x minus 1 over x minus 4. I'm going to clear my fraction here by multiplying both sides by x minus 4. And pretty much you can't have too many parentheses. On the right side of your equation, the x minus 4's cancel. On the left side of your equation, you're going to double distribute. That's why those two sets of parentheses are really important. And just like with the last problem, I need everything on the same side so that I can either factor or use the quadratic formula. And this ended up being another nice factoring problem. So two numbers that multiply to 21 and add to negative 10 are negative 7 and negative 3. That means x equals 7 and x equals 3. Again, we have to double check that they both work. So I'm going to scroll way back up to the top. And 7 and 3. So if I plug in 7, I'm good, good, good. All positive in my parentheses there. So that's lovely. If I plug in 3, my first ln here, I'd be taking the ln of negative 2. And that does not work. So 7 is a good solution. 3 is extraneous. So that was an example of having logarithms on both sides of the equation and being able to condense and cancel. Number 3 was an example of having logarithms on one side of your equation, and so we did condense and use the exponential. And on the next video, you'll see some exponential equations that we're going to solve using exponent rules and using logarithms.